I owe a lot to Midwestern University. That is my first statement. And I sincerely, if it was not the support which I got here from my college, from the research, I think this would not have been possible. And today I deliberately was waiting for the right time, so that I can go through the process and tell you the story, the science behind how it evolved, and what all we have done. So right now, the technologies which have originated from Midwestern University, it is not a small thing, it's a big pipeline now. 8 indications. Number 1, hypovolemic shock. And that can easily expand into septic shock and other kinds of shock. But our focus is laser focus, get the product approved, and then expand into other indications. Once you start diversifying into early on, nothing will happen. Second, I'm indebted to my collaborators in Greece. We did not have facility to do swine studies, and they are very expensive. The collaboration, that is one example of collaboration. I did not know these guys, and I wanted swine because rat data was coming out very good, and the type of model which we follow, if the FDA's guidelines are that if the technology or the product works in hypovolemic shock in rat and swine model, it has always worked in human. So rat, we did experiments here, we found very promising results, and now swine was the other issue. Either we had millions of dollars to spend, but we didn't have, so I kept on emailing, and ultimately this group in Greece, which was doing all the swine studies, they said that we are willing to collaborate based upon our publication. So 3 papers have been published, and in their collaboration without any cost to us. So that is the help of collaboration which can happen. So so the cardiac arrest was done by them. We didn't have resources here. So the professor whom I'm collaborating was the president of European Cardiac Arrest Society, had interest in that. He worked first on hypovolemic shock in swine model, found very promising data, which I'll show you. Then he said that, I want to test in cardiac arrest. I said that, Theodore, please be careful, because if you find negative results and you publish, you are going to destroy me also along with that. So he said, let me try. So he did initial experiments, found positive, and then ultimately full-blown study was done, which is now published. Then recently we came across the human data, and in human data it was pointed out that there are some indicators that it may be useful in acute kidney injury, so we filed the patents going through the process roughly about 3-4 months ago. Then another important thing is stroke, Alzheimer's disease, spinal cord injury, ALS. These are all from one compound, which Seema, Mary, Amresh, these are the guys who have worked very hard in identifying how we can regenerate the neurons based upon hidden stem cells which are present within the brain. And diabetic ketoacidosis is another indication which so when the initial discovery was made, that was in 2009, we declared to Midwestern, filed the disclosures, and ultimately we decided that one of my partner in Europe, he was running a pharma company. So I asked him that, can you partner with me and start a company with, so we incorporated the company October 21, 2010. And next year we incorporated a company in India, which became a 100% subsidiary of the US company. Basically the idea was we cannot generate $100 million to do the studies in US, but in India the cost was very less and the resources were available, so we thought, let us try that route and see. And there were a lot of hurdles in that route. I mean, I'll tell you that financially, nobody in US wanted to invest in India, so get out. They just literally told us, get out. We don't want to talk. And then ultimately now the time has come when the human data is coming out, people want to talk, and potentially invest. So the two licensing agreements were done, and one was done on January 3rd, 2011, that's for shock and diabetic ketoacidosis, and the second was in 2014, January 28th. The company is basically, these are the lead products which are being developed, and ultimately we want to bring them from India into United States and Europe. So my whole focus for today, instead of all 8, my focus is I want to take this as a story, how it evolved, what ideas, how we got the idea, and how we move forward. And right now we have completed phase 1, human. Phase 2 is complete, and application for phase 3 has been submitted, and I may be called for face-to-face meeting end of this month or early next month to initiate phase 3, and that will be the final, and after that launch. And I'll tell you, the data which has come out is so promising that already thinking of launching, the process has already started, that how we should be launching. Cardiac arrest phase 1, same compound is complete. Phase 2 planned, but we don't have resources, financial resources to move forward. Acute kidney injury, we will down the line look for in phase 3, when we are doing for hypovolemic shock, we will go with biomarkers for acute kidney injury also. Stroke, phase 2 results, 28 patients have been enrolled up till now. And I don't have the data because stroke is being monitored for 3 months, 90 days. So it will take time. Hypovolemic shock patients are monitored for 28 days, so we can generate the data quickly. When it is 3 months, then it takes time. So, but today, for the first time at Midwestern, I will show little bit of stroke data, human stroke data at the end. Alzheimer's disease monitoring is for 1 year. So we do not have any, 10 patients have been dosed in Alzheimer's disease, but we do not have any results from that. And they are all blinded. So stroke, the protocol was defined as there are 40 patients which have to be done in phase 2. And once we reach 20 mark, we can start the unblinding procedure. So now we are at 28, so the procedure of unblinding has taken place, and I will show a little bit of result, which we have. Spinal cord injury, October 1, we got permission to dose the patient for spinal cord injury. So right now, site initiation process is going on. It's a very complicated process to initiate clinical trials. So there is site initiation visits, the drug has to go, randomization procedures have to be established. The team has to be trained for the protocol. So before we can dose, it takes about 2 months of intense training at every site. If it is a multi-centric site, you can imagine if there are 10 sites, so 10 different training programs are going on at one time. So that process has started. ALS, once again in collaboration with Midwestern at veterinary school, there are dogs which are suffering from degenerative myelopathy, and these dogs are exactly similar to ALS in humans. So right now, yesterday I came to know that 5 dogs have been dosed, and we will see how the progress is. Well, after 10 dogs, then we'll make a decision whether to go for human ALS or not to go for human ALS. Diabetic ketoacidosis is another. So how it happened? I've been working on this compound called Centhaquin for ages. When I was in India, I did my MD, and after that, I started working on this compound. This compound was being developed for central control of blood pressure, central hypotensive, just like clonidine. So we worked on it and found out the mechanism that it acts on alpha-adrenergic receptors. Just like clonidine, structure was very different from clonidine. But when it went to phase 1 human studies, there was so rapid development of tolerance that first day, the blood pressure dropped, and after the second day, no drop in blood pressure. So rapid development of tolerance led to this compound was abolished. But I had a little bit of this compound, and I was working, and John Creighton, that time was the chief of psychiatry. So we started collaborating, and we published a couple of papers and identified that besides adrenergic attacks on 5-HT receptors, but the dose was much higher, so we stopped, and in between I got grants for artificial blood with Baxter. So I started concentrating on artificial blood, and with Baxter, that gave me a lot of experience in hypovolemic shock. Basically, the product went all the way to phase 3 clinical trial, and then it failed. So that was a big setback. So 1999 or 2000, it failed. So after that, I thought, I should start my own thought processes and invent something based upon all these. In the meantime, I moved to Midwestern University. So when I moved, I was cleaning up the drawers, and I found this compound. So that time, Dr. Manish Lavale, who is the director of science, handling all the science in India, he was the postdoc chair. And Prabhu Hall was the lab. And I still remember Jim said that this is your lab, and he vacated that lab and gave it to me exclusively to do cardiovascular work. That was the first time we started. And in that lab, we found that lactate level always went down with this compound. We were just studying for cardiovascular activity, trying to identify some receptors, and even after 25 years of that compound lying in drawer, it was still active, and it decreased lactate level. That observation, I said that, okay, now let us do the hypovolemic shock model. And we found that it was effective. Then pharmacology has to be done. We have to do dose response. We started doing the dose response and found that higher dose became less effective. So then said, okay, reduce the dose. So the dose at which the blood pressure fell down, we started reducing the dose, and at 15-fold lower dose, it came out to be a highly effective resuscitative agent. And we published a lot of papers. So 2009 was the time when we started filing the patents on this. And patent protection is a continuous process once again. You file first time, then you file divisional, after divisional, till you get the maximum protection. And then if there are some new ideas coming in, then you file continuation applications or new application. So right now, I'm so happy to say that already preparation for launch in 2019 are beginning. Now let me go to the story, how it happened. This was the first tracing which was done at Prabhu Hall. So on the top two, these are the blood pressure, and bottom is the heart rate. So let me come here. So what we do is, this is blood pressure, this is the mean blood pressure, this is heart rate. So what we do is we bleed the animal, bring the blood pressure down to 35 millimeters mercury, keep it for 30 minutes, then we resuscitate. You can see the compound, very effective increase in blood pressure, both diastolic, systolic, pulse pressure also is pretty good. The most surprising thing which led to patent was this observation that there is a decrease in heart rate. Every vasopressor which we know today increases heart rate. And just this observation said that there is something different. And it consistently always produced a decrease in heart rate. So then we put pressure volume loops in which simultaneously left ventricular pressure and left ventricular volume was being recorded. So the key thing is, this is the stroke volume, which means that every amount of blood pumped out of every beat. And this is the recording, 60-minute recording condensed into 60 seconds. And you will see the bleeding. Once the blood loss occurs, the pressure will come down and the stroke volume is going down. And when we resuscitate with ringer lactate, not much happens, only 10 minutes of recovery, and after that it starts fading back again. So you can see the stroke volume has reduced significantly. So now this is the shocked animal, in which rat animal, All these experiments were done in Prabhu Hospital. And you will see how gradually the stroke volume starts improving. And the pressure starts building up. So these findings we published in American Journal of Emergency Medicine, and this is the control. This is hemorrhaged animals with hypertonic saline. This was another experiment we did. There is some recovery, but transient. Here all the animals died to 40 minutes, and here all of them are surviving. Lactate is the most important indicator of mortality. If blood lactate level is high, mortality is high. So this was another series of experiments in which we measured the pH. Once we see that pH acidosis is being reversed by the compound in lower doses. And lactate level you can see from 7.6 down to 1.9. So significant. Base deficit also going down. So all these indicators were that this may be an important thing which we are embarking on. And lactate level is so important because it's a reflection of blood circulation. Muscle, brain, skin, RBCs, they produce lactate. And once this lactate is coming here into the circulation, liver is a Cori cycle which disposes of the lactate. So here there is production, elimination. So blood lactate level, if the elimination is poor, production is poor, production is increased and elimination is poor, lactate levels will go up. And that's a reflection of circulating blood volume. So we did, norepinephrine is used very extensively. So we did studies to see whether we bled the animal, gave norepinephrine infusion to bring the blood pressure to 70 millimeters of mercury from 35 and measured the lactate level. So we can see that the lactate levels are significantly lower with the drug treated plus norepinephrine. And simultaneously, we also did a study in which the whole idea is to have small volume resuscitation because large volume will cause lung edema and many times death. Two important factors for death are arrhythmias and lung edema. So extravasation of fluid and arrhythmias are the important. So here we gave, once again, we bled the animals, brought the blood pressure to 35 millimeter mercury, then gave 1/5 of the volume of blood loss. And then resuscitation, we monitored up till what time the blood pressure is above 35. And once it reaches 35 back again, we gave 1/5 of the volume of fresh blood. So body weight is this comparable, blood loss is about 8 millimeters, infusion is also 1.5. And you will see that the difference is that time for blood pressure to fall back to 35 millimeter is 55 minutes and here 161. Time to death 79 and overall survival time improves from 134 minutes to 266. This was the study done in Greece and 50% of the blood was lost in these swine. And what happened was resuscitation was done by Ringer's lactate infusing and bringing the blood pressure back to baseline. 2.2 liters of fluid was needed to bring blood pressure back to baseline, and with the drug, only 300 ml. 2 hours later, 3 out of 10 animals survived, all 10 out of 10 survived here. 0 survived, 24 hours later, 9 out of 10 survived. So all these findings are published in, and now this was the surprising thing which we observed, which we had observed in that, and same came out to be in the swine study. Cardiac output, you can see with the black Centhaquin, it is significant increase in cardiac output. The most surprising thing was decrease in vascular resistance. So if there is a patient where cardiac output is increasing and we are pushing norepinephrine, which also constricts the blood vessels, arteries particularly, the blood is not actually going to the tissues and organ failure can happen. Here the blood vessels, arterial side is getting dilated. Therefore, improvement in cardiac output, really that blood goes to the tissues. So mortality from here all the way, no mortality. So these findings are published. Then there is a lethal triad when there is massive blood loss There is hypothermia, which leads to metabolic acidosis, this also, and coagulopathy. When we infuse a lot of fluid, what happens is that the dilution of clotting factor occurs, and the clot which is formed, many times it is a loose clot, and it dislodges, and bleeding starts again, and most of the time death occurs because of that. So we studied all that mechanism, and this was again one instrument we have at Midwestern, and Gwen was the person who was expert in using that. So what it does is that blood is here, and this rotates, and this diameter or the width tells us the strength of the clot which has been formed. So basically MA, this is the width which is telling us that how strong the clot is. And this R is the rate of formation of the clot. So we did studies, and we found that with this one is with heparin, you can see this width has gone down with heparin, but when we add our drug, these two are the same, and here these two are the same. So basically it is not interfering with the clotting mechanisms or clot formation. Similarly, these are the values for this, and then this Centhaquin does not inhibit fibrin formation or platelet aggregation. So basically this was another important study, that the compound should not be interfering with coagulation process. If it interferes, it can cause damage. Then this was recently published, once again, that from the Greece collaboration, that in swine studies, central venous pressure is little bit up. It was not significant, but little bit higher central venous pressure was there. Once again, arterial pressure, this is blood loss. Once there is recovery, the blue ones are significantly higher than, so the blood pressure improved significantly more than the control. Systemic vascular resistance, significant decrease once again. So arterial dilatation is taking place. Cardiac output increase. So we have now a lot of publications in rat and swine model indicating that systemic vascular resistance decreases, cardiac output increases, and overall blood pressure improves. So the cardiac output increase will lead to a greater increase in blood pressure, while systemic vascular resistance decrease will lead to fall in blood pressure. But the overall effect is rise in blood pressure. Horowitz index, which is a lung function, we can see significant improvement in Horowitz index, and wet-dry ratio, that means pulmonary edema also is not happening in these. Mortality in control, 6 hours, 2 animals died, 8, 1, 11, 3, and this is the mortality, and here 1, 1, 1. So highly significant improvement in survival. So publications are, these are some of the initial publications in rat, where overall the effect is increase in cardiac output, decrease in vascular resistance, decrease in lactic acid, improve survival. So this is another experiment which we did in, Mary was involved in doing this in the lab, where blood loss occurs and brain perfusion. You can see now there's significant decrease in brain perfusion. And here we gave the compound Centhaquin, and you will see brain perfusion starts improving. So this experiment was important because now at the capillary or the tissue level we are showing that there is an improvement in circulation which is taking place. Then Dr. Andurkar and I, we have been collaborating, and his very important role in this is to identify, so we did 67 receptors to see where it is acting, and predominantly it is the alpha adrenergic receptor. Then after his findings, we started doing experimental studies using alpha-2 blockers, and found that when we use alpha-2 blockers, the efficacy is completely blocked. So here it is effective, survival is improved 100%. We use this, survival goes down. And same is lactate level and many other things which we have done. So proving that alpha-2 receptors are involved. So how do we act? There are alpha-2B receptors and alpha-2A receptors. B receptors are on the venous side. And 60 to 70% of our blood is pooled on the venous side. 30 to 40% is effectively circulating and supplying oxygenation and tissues. So what this compound is doing, because of venous alpha-2B, it is diverting that blood into the heart. And because of that, cardiac output is improving. And because of improvement in cardiac output, tissue perfusion is. And simultaneously in the brain, it acts on alpha-2A, which is sympatholytic, and it will dilate the arteries. So overall mechanism is stimulation of alpha-2B, venous receptors, increase venous return, increase cardiac output, heart pumps more blood per beat, as we saw in stroke volume, improved blood perfusion, better oxygenation. And alpha-2A in the brain, sympathetic vasodilatation. So blood vessels dilated, blood flows easily through the vessels to improve perfusion. So that's the mechanism what we have. Now compared to what are the present vasopressors, so the present vasopressors, the key difference is they increase heart rate, this one decreases heart rate. So increase in heart rate means in a dying patient, increase in heart rate means more oxygen will be needed by the heart. So that we do not want that. Then another thing is vascular resistance increase, here there is decrease. Mechanism is cardiac output increases because of increase in heart rate. Here cardiac output increases by increase in venous return. Very important, beta receptors are involved, here they are not involved. We have pharmacologically, biochemically, and Dr. Andurkar's studies on binding, they all indicate beta receptors are not involved. So the chances of arrhythmias, which are with present vasoconstrictors, is eliminated. Then isomers, here there are no isomers, so very clean manufacturing. Fluid extravasation, there is no fluid extravasation which is there. So
is currently managed by increasing blood pressure using cristoids, colloids, and vasoconstrictors. The infusion of vasopressors needs careful titration. Their use causes an increase in vascular resistance and heart rate, which results in the rise of blood pressure. However, the use of vasopressors may have side effects such as an increase in peripheral vascular resistance, which may lead to a decrease in blood perfusion to the tissues, cardiac arrhythmias, fluid extravasation. Overall, the survival rate is very low with the presently available treatment. PMZ-1620 is an effective resuscitative agent by acting through a unique mechanism of action by stimulating alpha-2B adrenergic receptors. More than half of our blood is pooled on the venous side and does not participate in supplying oxygen and nutrients to the tissue. When PMZ-1620 is administered intravenously, it stimulates venous alpha-2B adrenergic receptors to produce venous constriction and return the pooled blood to the heart. This results in more blood pumped out of the heart with each beat, producing an increase in blood pressure. Simultaneously, PMZ-1620 produces dilation of arterial blood vessels due to reduction in sympathetic drive. In addition, PMZ-1620 appears to block FA1 adrenergic receptors on the arterial side of the circulatory system, thereby decreasing arterial resistance. Combined effect of stimulating alpha-2A and alpha-2B receptors leads to an increase in cardiac output and arterial dilatation by PMZ-1620, thereby enhancing organ blood perfusion and enhanced supply of oxygen and nutrients to the tissues. PMZ-1620 has demonstrated significant improvement in survival following hemorrhagic shock. It offers several advantages over currently used vasopressors. Concerns of potent vasoconstriction limit the use. PMZ-1620 in contrast produces arterial dilation to enhance blood supply to the tissues. The most common adverse effects of presently used vasopressors include arrhythmias, fluid extravasation, and ischemia, which has not been observed with PMZ-1620. Current vasopressors need constant intravenous infusion and needs to be titrated carefully, whereas PMZ-2010 is administered in 10 to 15 minutes infusion with no need for titration. PMZ-2010 has a high safety margin. PMZ-2010 does not act on beta-adrenergic receptors and has no isomers. This provides a significant advantage over current vasopressors because of minimal risk to produce cardiac complications. PMZ-2010 is effective in small volume and is not likely to produce fluid extravasation as reported with current vasopressors. It significantly reduces the amount of vasopressors used for resuscitation, thereby limiting their adverse effects. In summary, when PMZ-2010 is injected intravenously, it acts on alpha-2b receptors in the vein to produce venous constriction and acts on alpha-2a receptors in the brain to produce sympathetic action, leading to dilation of the arteries, thereby improving cardiac output and tissue perfusion. This is a novel first-in-class mechanism to resuscitate patients with hypovolemic shock.
So the patent position is, these are the issued patents: Australia, India, Japan, China, European Union, Canada, US. There was a query, we are trying to resolve that, and then soon we think that should be issued. Phase 1 has been completed, I'll show you the results. Phase 2 has been completed, I'll show you the results. Phase 3 submission is in progress. So in other words, low volume resuscitation, increased cardiac output, decreased vascular resistance, improved tissue perfusion, and improve survival. Important thing is, we think it is first in class. This is a unique mechanism which has not been explored to resuscitate. It's a first in class. The importance of first in class is like statins. Anytime when we think of statin, it is Lipitor which comes in mind. And after that, so many statins came in. But ultimately, it is that name always sticks around. The unique mechanism, increasing cardiac output and decreasing vascular resistance. Dr. Andulkar's area, all synthesis, he is the one who initially helped me synthesize, streamline the process, and chemically 99.8% purity all the time. And today, I mean, because of his help, the manufacturing and all that is so easy that we can manufacture millions of vials in no time. Stability, it has been found to be stable for 12 months, and still those studies are ongoing, and we think that it may increase to 12 months also is a very good stability. I mean, 3 years will be ideal. So the manufacturing is done in amber vials because it is light sensitive. So 1 milligram is put, and ultimately the dose is 0.01 milligram per kilogram. Toxicity, I won't go in detail, but a lot of money is spent in toxicity, because without toxicity studies you cannot give in humans. So because we chemically modified the compound from original, that helped in patenting, as well as because we had, for hypertension, it was being used orally. Here we had to make it injectable. So our projected dose is 0.01 milligram, 100 milligram, no toxicity. And then in rabbit, 9.5. That was the. So 28-day toxicity, once again, not much of abnormality was obtained till 1 milligram. So then, very, very high dose, still no toxicity. So no observed adverse effect level of this came into 1 milligram per kilogram. And our projected dose is 0.01. So way, way lower than this one. And in high dose, 5 milligram, we saw congestion of blood in the liver and various organs. But the good thing was, after 15 days of recovery, they were all normal. So even at 5 milligram, the toxicity which was observed is reversible. So all skin toxicity, reproduction, genotoxicity, they were all well tolerated, no issue. Then dog toxicity, once again, we did not find any problem even till 1 milligram per kilogram. So this dog toxicity in India, when we did 2 male, 2 female, and just because of one, we missed the US FDA's guideline. US FDA wants minimum 3 male, 3 female. And this is just, I'm highlighting the example that you make mistakes and we had to do the whole study again. But the good thing was we applied to NIH for SBIR study and they funded $277,000 to repeat this in US. And that study is complete now. So we did, instead of 3, we went ahead and did 4 and 4, a little bit higher. And everything went very well. Then once again, Hurg assay, we have to see that there are cardiac problems or those kind of things cannot happen. So before we go into humans, this assay has to be done. And we found that compared to the potential toxic producing, this is much higher concentration which is needed. So basically indicating safety in patch clamp techniques and all those techniques. So it was found that it is safe. Then this is the final data which came out of Hurg assay and inhibition of currents. Then another SIDS collaboration where we did all the SIP cytochrome P450, although in hypovolemic shock it is not needed, but we are going extra mile to see whether cytochromes are disrupted or transporters are doing. So we have completed that study and it shows that there is some cytochrome P2D6 inhibition which may occur. Transporters, not much of effect on transporters. Excepting PGP, there is some little bit of action which may be looked into. This is SIDS data. So his projection was it will act on 2D6 and clearly he projected and it acted and we found that it did act on 2D6 and potential metabolites are these. Now we are embarking on possibility of identifying these metabolites to see we can generate a second generation compound down the line or not. The team, we have in-house clinical operations, clinical data management. So all the clinical part which is needed, a huge team has been assembled which is looking after all the clinical trials of our project. These are the team which is members of the team. Let me come to clinical results which are very exciting. Phase 1, 25 subjects were dosed. We did single ascending dose, multiple ascending dose. This is the projected dose. First toxicity we found was at 0.15, 15-fold higher, and that toxicity was hypotension, and which was expected because alpha-2A activity in the brain will predominate at higher level and will produce hypotension. And it resolved without any intervention. So 1 hour, 1.5 hours later, it was all gone. Phase 2 trial, which is designed like this, where every hospital, it was a multi-centric trial with blinded randomization, so all proper controls. So every hospital which is using their own standard of care treatment, they continue to use. Supposing if some hospital is using norepinephrine, they use norepinephrine. Another hospital may be using phenylephrine, then they use. So we did not want to intervene with that because these are very difficult trials, very sick patients, they are almost on the verge of death. So we cannot interrupt with anybody's protocol of standard care. So the results are as follows. So these are the hospitals ranging from 100 bed all the way to 2,000 bed hospitals. So small to big hospitals. These are the numbers of patients they were screened, 137, and date of screening or initiation, we even kept a record of that. Total enrollment 50. So 137 excluded 87, 50 enrolled, and 26 in control, 24 in this. Final completed the study is 23 and 21 subjects. What are the results? Age, very comparable. Body weight, 64, 64. So demographics are all comparable. Normal saline, they needed 1.3 doses, and here it is 1.2 dose, very comparable. Blood loss, which may be a very important indicator that two groups may be different. Blood loss, hematocrit, you can see very similar blood loss in the two groups. Injury scoring system. This is an indication of how much accident and how much organ damage and all that has happened. Very comparable, statistically 0.45. So no difference between the two groups. Total amount of fluid which was given to both the groups, 0.39 p-value, is very similar to both the groups. Amount of blood products given, 0.99. So I'm showing this data mainly to show that there was nothing extraordinary done in any group. They were very, very similar in both the arms. So number of patients requiring vasopressor, 42%, here it is 26%, little bit less. ICU time which is spent, it is 0.2, comparable. Little bit trend is there, that there is less time in ICU. But time on ventilator, 2 days on ventilator, here it is less than 1 day in a ventilator. But error bars are high, it is not significant. Serum creatinine levels from 9 to 0.7 and 1.3 to 0.72. And when we did individual level of creatinine level, the significance level came quite high compared to this also is significant, but here there was. So this gave us an idea, and then Amresh and some of the advocate fellows, they did experiments here, and we found that kidney is an important organ which we can target, and that's how we filed the patents. Glomerular filtration rate also improves, statistically 0.0006. Now, the most important indicators in shock are blood pressure, lactate level, base deficit. These are any one, if we achieve, US FDA will approve it. Any one of the biomarkers in this. So let us see the data. Blood pressure, green is the compound which we are developing, and red is the control. And control, mind you, this also is the standard of care. It is not that they are not under standard. This is the best the patients can receive at present day. And we can see that blood pressure is. And when we plotted individual values, these are the individual values, and you can see here there is level of significance is there, but 0.0001. Diastolic pressure, very clear. And statistical level, here it does not reach the statistical significance. Here 0.0001. And diastolic pressure is even more important than the systolic one to sustain life. Base deficit, instead of deficit, it becomes excess. Complete reversal of base deficit. Individual values, 0.0001. Blood lactate levels, one of the most important indicator of mortality, from 4 to 1.4, 4 to 3. And when we plot individual values, we can see that it did not reach the level of significance here, 0.0028. Now, when I analyzed the data, there were two patients which are a lot of interest, patient 10 here and patient 12 here. Both are female. And because of hysterectomy and pregnancy, which went bad, massive blood loss. Almost in both cases, it was 3 liters of blood which was lost very quickly. One is 24 years old, 31-year-old, 24 fell in the saline group, and 31 in the treated group. And lactate level, you can see in the saline group, subject 005, 11, and this patient died in 6 hours. At that time, the lactate level was 15. 006, 31-year-old, 17.41 lactate level. And many of you are clinicians, and 17.4 lactate level, hardly anybody survives. And this patient survived. 2 patients died in the control, 0 in the treated group. So now when we designed the phase 3 trial, there was an ethical dilemma that you have a drug in phase 2 which has shown efficacy in all the 3 parameters which are vital. And if you are designing a trial in which you are not giving the drug, are you doing ethical thing or not? So after a lot of debate and consultation, we designed the trial in such a way that we will be giving 1 patient saline or control and 2 patients the drug. So that's how at least we can balance that there is and there was another issue you can go is one patient control and 4 patients with the treatment. If you do that, then the number goes up a lot, because in control you have to have some decent number too. So we went with 1:2. So overall the results are showing all the clinical surrogate points are statistically significant and are improving the standard of care. So now where is the leadership? Here is the leadership. The name Centhaquin is a misnomer. This will be gone. That name is not appropriate. So I wanted to highlight this also, because the names of any drug has to be approved by Geneva. There is a committee, INN, which is non-proprietary name. So our leadership is such that even non-proprietary name we are going to give. And these are the 6 names which we have proposed to Geneva Convention Committee. And all these are expensive. They charge $12,000 flat fee first, and then there are consultants who almost $25,000 they charge based upon that. So ultimately, just like statins, this compound will be in future, if it is approved, it will be Algram. Then trade name, that also is a very complicated process. Out of thousands, we have narrowed down to now 20, and we are about to reach 6 to 8 names, and ultimately. And these are also complicated in the sense the worldwide 130 countries, they have to go, and every FDA regulatory agency conforms with that name, and that name is not in any other language which is not desired, or it can indicate that it may be saving lives, or some indication is that those names are not allowed. So, so it's a big process which we are going through. And we can imagine that how much leadership worldwide we are establishing in this compound. So up till now we have first-in-class preclinical validation complete, IND filings are done, phase 1 complete, phase 2 is complete, phase 3, now preparation of project launch and commercialization, life cycle management will start. So the science which comes from Midwestern, how that science evolves, so I have not gone into the depth of publications, but I took an overview just to come up to. So payments, now there are 23 issued patents in the name of Midwestern University. How we market projections, now there are experts, Gaylord is here, he is the chief financial officer, all he does is financial projection and leaves me for science. So his projections are 1990 December we should be able to launch, and 0 to 10 market share, so 5% market share out of 22 million in India the patients are. Between 2 to 4 million, we took a conservative number of 2 million. So about 100,000 patients in the first year, then going up to 700,000. Net realizable value per patient is coming to about $300 to $325, and the numbers which come to about 30 million going to 277 million. So if this is successful, then based upon these net realizable values, the university royalties will be about 0.9 million going all the way to 6.8 million. And then stroke is another example which we are moving forward very aggressively. If we have success in stroke, then the cumulative royalties in 2020 can go from 2.4 million all the way to 19 million. And now this is only India. The rights are all worldwide, so there is a lot of expansion and litigations, all can be done. So let me show for the first time which I did the analysis today for stroke data. So this is the modified ranking scale in which 0, no symptom, and 6 is death. Number of patients are very less. Control, there is some improvement. Statistical level is 0.14, and with the treatment. So, but I have to be, I'm telling, very cautious. This number can completely change because the number is very low right now. So it can completely change, but initial indications are positive. Then we have Barthel index, which is again scored on basis of 10-item scale, 100 maximum score, which are fully independent and physically functioning, and 0 is the lowest score. From here they improve this way, and here the improvement is really significant. So we are keeping our fingers crossed because it is just 21 patients and the number of patients is very less. So, but it can change dramatically. But initial indications are pretty good. These are some of the publications and which we have done, and I will. Mark just left, but a lot of pharmacokinetics which has been done. Mark Sheets, his group has been involved in doing all the pharmacokinetics. These are the publications. So I'm thankful to a lot of people, right from Midwestern to outside to for all the help which has gone into this project, and particularly I'll say that Midwestern gave me the platform. Without that platform, it would not have been possible. So I'm very thankful to Midwestern University which gave me the platform to do these studies, and then ultimately all this is happening. So thank you so much, and I'll be happy to answer any questions. Have some questions. Yes.
How quickly is the Centhaquin cleared, and does it break down into any types of metabolites?
Half-life is 1.1 hour in humans. And initial studies are indicating that it will break down. 2D6 is the metabolic pattern, which is. But what happens is that we have seen the FDA, which approved the drugs in past, they don't even need these studies because it is acute, it is 1 time, 2 times, so not much of consequence. But our intention is to use that, since we have the expertise, to use that to generate future generation compounds or have in-depth knowledge what all is going on.
So you've done a lot of, how many of those metabolites have you identified?
We are in the process of identifying.
Right.
So those were the projected ones based upon hypothetical modeling.
Yeah.
Are there any studies on Centhaquin and angiogenesis or neurogenesis?
No, we have restricted on to this, and our future, I want to now focus on acute kidney injury. Once this goes into phase 3 and that process starts, then I want to concentrate on acute kidney injury because that's a huge issue, which is very important for an acute kidney injury is involved in, for example, contrast media when we use acute kidney injury, vancomycin or other antibiotics, acute kidney injury. All types of shock, septic shock, hypovolemic shock, all types of shock are accompanied with acute kidney injury, and down the line it converts into chronic and patients are on dialysis and all that. So if we can prevent that, it will be a useful thing. Yes, there was one more question. Yeah.
How is the drug cleared?
Hepatic. It is 2D6 metabolism predominant. Any other question? No, thank you so much.